Afternoon all. I'm in the process of building a new control panel for my arcade machine made out of Perspex. I've been building a new one because I want the old one just kept around in case I want to go back to stock in the future. So I'm building a new one laser cut out of Perspex. The problem with the laser cutting is obviously it's flat, and to fit the arcade machine I need a way to bend it. So this is the prototype proof of concept I built using neochrome wire and an old 19 volt 3.12 amp power supply. Up here's the neochrome wire I got from JCar, gauge 30 if I recall correctly, about $4. I've done the maths here. It does work. It should stay below like the 400 degree breaking point. It runs about 235. But yeah, this is the prototype, and as you can see here, it does actually work, and I have bent stuff with it. So let's have a look at the final. Okay, so here's the final Perspex Bender. It was made from some tabletop I had lying around the shed. I've routed channels and sections out of this tabletop to fit the 20mm aluminium U-channel, and small routes around the outside to keep the cords and cables out of the way to stop interfering with the hot neochrome wire and getting tangled with the Perspex. So here's the neochrome wire, and up one end is attached to a spring to keep tension on the neochrome wire, because as the wire heats up it expands, and the last thing you want is the wire to sag, which will give you unbalanced heating, and at worst it could even give you an electric shock if you touched it. This piece of Perspex has been on hotbed for around 6 and 7 minutes. You can tell it's close to being ready by looking at the reflection on the Perspex. You can see how the reflection is starting to distort. This one could probably do with a few more minutes to get it really pliable. You need to ensure as well that the edges as well as the center are all heated up equally. Otherwise it can go bad, and I will show you what I mean by go bad in a minute. So let's see if we can bend this Perspex. Bear with me. Here we go. So we'll give it a bend. You can tell by the amount of force I've got to put it on a right there that it could have actually done with a minute or two more. But it doesn't really matter. Now at this point of bending, I'd be close to the tap, and once I've got it to where I want it, which is sort of what I'm just holding there for a test, I've been running it under cold water to help it cool down a lot quicker. This should, that will just help it cool down and stick and stop it from bending back. So what did I mean about the edges and disaster? Well, here's some white Perspex I did last time. As you can actually see here, the edges have cracked quite severely because they weren't hot enough. This actually happened on both edges, so you should really ensure that the Perspex is properly heated. I've actually ordered an IR temperature sensor just to ensure that all the sections are 160 degrees centigrade or slightly more, and that should give you a nice clean bend. So up here I've got a piece of wood that I carved out just to make it look fancy. Really all it is a right angle for the bending unit, so you can be sure that when you put your piece of Perspex on there that it doesn't bend at an angle, unlike this one that I previously cut there, which you can see is on an angle. So just quickly, so we've got a 19 volt power supply on this thing over here. It's just standard laptop one. You need to ensure that this is strong enough to actually run the neochrome wire in there. I've got a calculator which I'll put in the description. There's nothing too fancy. They've just got allocator kits on the ends, and they just connect to the wire on screws. This is actually 50 centimeters of wire, actually a little bit more. It's more like 55, and it runs at about 250 degrees. Yeah, that's really all there is to it. Let me know what you think. Thanks.